Hi, in this video I am discussing Edexcel IAL Mathematics Mechanics M3 paper, January 2022 unused paper. All the questions from this unused paper will be discussed in this video. Okay, question number one, this unused paper, January 2022, Mechanics M3. The first diagram, I changed the diagram to make it easier to understand. The question says that a light elastic string AB has a natural length 11A and the modulus of elasticity is 6 mg. So that means this is a natural length without any particles attached. The string has the total length of 8a, but it is light, so it has no mass, so it won't have any tension if you just hold it without attaching any particle. Okay, now what happened? A particle of mass 4m is attached to the point C on the string. So I mark the point C on the string, which is AC is equal to 8a, and a particle of mass 2m is attached to the end, bottom end B. That distance from A is 11a, or from C it is 3a. So the mass of the end of A, the string is attached to the fixed point. So the diagram shows that the mass attached to point C is 4m. The mass attached to point B, which is called Q, the name of the mass is Q, which is 2m. Mass attached to C is P, which is 4m. Okay, the question is find the length AP. So that means find the length AP means now what could be the position of the C? C will move down, extended. AP means the length from A to the point C where the particle P is attached. What is the length? Okay, so here what happens? The upper part will have tension from A to C. That string is light, so it has no weight. But that string has tension due to the total weight of Q and P. You would have seen that when you hold a slingy normally the weight is not negligible. Say if it is a metal slingy, copper slingy, if you hold it, you will see the slingy looks like this. Upper part will have larger extension like this, and the extension gradually decreases. You would have seen that. The reason, when you consider this portion, there the tension is due to the weight of the portion below that point. So the weight of this portion acts here, so the extension is more. But at the bottom point, when you see the extension is very small, the reason is, for example, if you think about what could be the tension here, the tension acting here is only the weight of the portion below that point. But when you consider tension here, the tension here is equal to the total weight of the slingy below that point. So the tension is more here, so extension is more. Here tension is less, extension is less. The same way, analogy, you can compare it. When you think about this portion AC, which has length 8a, anyway that portion has no weight, it's a light string. But in that string, portion of that string 8AC, the total tension is equal to 4m plus 2mg. Why? The reason is the total weight acting, the total tension acting at C will be the portion AC is equal to the total weight below the point C. Total weight below the point C is the tension acting in this portion from A to C. But when you consider the tension acting in the portion E to Q or C to B in this length, what could be the tension? That is only due to 2mg. Okay, so by using that and by using lambda equal, tension equal lambda over L into X, we can solve it. Very simple question. Say for example, I am going to find the first part. The first part, A part, they ask you to find the length of AP. Length of AP, yes. Find the length of AP. So that means I need to find the extension of this portion when it was at natural length, that is 8a. Now the C has come to this position, means this extension from here to here. This extension I can name it x1. This extension, let it be x1. So that yeah, I can put that x1 here. From here to here, that is x1. That is x1 is due to the total tension acting the portion on the length AC that is equal to total weight acting below that, total weight attached below that. Okay, so that is T1, or I can call that T1 is equal to lambda over L1 X1. The tension acting in that portion is 4 plus 2, that is 6 mg is equal to, lambda is given as 6 mg in the question. L1 is that portion, that is 8a. I am considering AC, I consider the length AC into x1. So I need to find the x1, that one. The extension of AC, how much? So x1 is going to be now 8a. X1 is going to be 8a. Already the natural length is 8a, extension is 8a, therefore AP, the total length is initial length 8a plus extension x1, that is 8a. So that is going to be 16a. That is the length AP. Remember that the tension acting in a portion is equal to the total weight or total mass attached below that. Okay, that causes the tension in the upper portion. Right, now the second B part, they have to find the length of PQ. Length of PQ means P to Q, that is length of this portion. So for that, I am going to write for CV. Again, T2, the tension acting in that T2, that is only due to the weight or mass attached below C. So that is T2 equal lambda over L 2 into X2. T2 is equal to 2 mg. Because below that portion, the only mass acting is 2m, equal lambda 6 mg given in the question. L2 is, this is 8a, this is 3a, the natural length is 3a. 3a x2. So solve it and find the x2. X2 is going to be, I'll continue here. So x2 is going to be, x2 will be a. Therefore, PQ, length PQ, earlier they asked to find AP, now PQ they ask it. PQ is equal to, length PQ is equal to, natural length it was 3a plus extension A, that is 4. That's the answer. Very simple question. Okay, question number 2, this diagram is given there. So there it says a particle P of mass m is attached to one end of a light inextensible string of length A. So the length is A. The other end of the string is attached to a point A which lies above horizontal, lies above a smooth horizontal table. So A is above O. A is above O. Clearly noted. A is above O, right? The particle P moves in horizontal circle on the table with a string taut. The center of the circle is O. AO is vertical and the string makes a constant angle theta with constant angle. Theta is constant angle theta with AO as shown. The angular speed is given 2g over A, square root of 2g over A. Find the range of possible values of theta. I need to find the possible values of theta. So the particle is touching the table. So there will be normal reaction. That normal reaction must have a real positive value. From that I can get a particular limit or particular range. Range means normally I should show theta less than something, greater than something. That is called range. They ask me to show that. But one range, one value I can directly say. They are saying A is above O. So A is above O means the theta cannot be 90 degree, because if theta becomes 90, the string will become like this, and if it wants to perform circular motion such that it touches the table, means if it wants to perform circular motion when theta equal 90 degree, means A must come to O, is it? So one range I can simply say theta must be less than 90. So what's the other value? I can find it by using the condition, the normal reaction greater than 0. From that I can get that condition. That's also not a big issue, a very simple question. So since a particle is moving on a horizontal circle, the resultant vertical force, according to Newton's first law, the resultant vertical force acting on the particle must be equal to 0, is it? Because otherwise, if there's a resultant force in vertical direction, the particle will accelerate in that direction, so it can't perform a horizontal circle. So horizontal circle means there is no resultant vertical force. So we'll think about the free body force diagram. That means all the forces acting on the particle. If I draw the particle and show the forces acting on it, the P, the weight is acting vertically downwards. Normal reaction I'll use capital N or capital R you can use. And the tension along this direction, that makes an angle theta with vertical. So the center is somewhere here, O, this is O. So when we consider the resultant vertical force, it must be equal to 0. So if I resolve vertically upward direction, N plus T cos theta minus mg equal to 0. So N is equal to mg minus T cos theta. We know it must be a real positive value greater than 0. We'll come to that point. Now when we think about the resultant force acting towards the center, that is called centripetal force. Resultant force acting towards the center of the circular path is called centripetal force, which is given by mr omega squared. That's the theory, you know that. So resultant force acting towards the center means this is vertical force, has no horizontal component. This also has no horizontal component. So the centripetal force only due to the component of the tension T sin theta equal mr omega squared. Okay, what is R in this triangle? If you consider this is the radius R, what is R? So we know that R is equal to A sin theta. Is it in this right angle triangle? AEO. R is equal to A sin theta. And also we know that mr omega square. Omega is given as square root of 2g over A in the question. So omega square we can substitute. So T sin theta is equal to m. Instead of r, I can write a sin theta omega square 2g over a. Okay, so we'll get an expression for t, and we can substitute that t in this equation, first equation. Okay, so get it, sin theta will get cancelled, a will get cancelled. So t is going to be T is going to be 2 mg sin theta, yeah, 2 mg. Okay, substitute this t in this equation. So for the first equation, n is equal to, this one first equation. N is equal to mg minus, instead of t, 2 mg cos theta. Since it's in contact with the table, n must be a positive quantity greater than 0. N must be greater than 0 means this is greater than 0. That is mg minus 2 mg cos theta greater than 0. So bring it to the right. So mg greater than 2 mg cos theta. So mg will get cancelled. That is 2 cos theta. I am taking too much of steps, but it doesn't matter. 2 cos theta less than 1. So from this I can say cos theta less than half. We know that cos theta less than half. So cos 60 is half. We know that cos theta less than half means, you know, in cosine function, when the angle theta increases, cosine value will decrease. So it must be less than half means theta must be, from this I can say theta must be greater than 60. Theta must be greater than 60. So we know that theta must be greater than 60. Already I explained it cannot be 90, because if it becomes 90, then, and also if particle P wants to touch the table, A must touch the O. That means we can't say A is above O. The question says A is above O, so it won't happen. So if it wants to happen, theta must be less than 90 degrees. So the range, final range we can write, theta must be greater than 60 degree, less than 90 degree. This is the final answer. Okay, question number 3. A particle P is moving along x-axis at time t second, x-axis, full stop, at time t seconds where t greater than or equal to 0. It's a positive value. P is x meters from the origin O and moving at speed v meter per second. the acceleration of P has magnitude 2 over 2x plus y 3, 2x plus 1 all in cube meter per second square, and it is directed towards O. So up to now what I read, I can put it on a diagram. Say this is the O about which the distance is measured. So the particle is moving in positive x-axis. So this is the way we take the positive x-axis. So at time t equal t, it's a variable type, the particle P is at x meters. So the x is measured in this direction, x meters from O, the particle is P, x meters from O, and it has an acceleration, x double dot I'll put it, acceleration is equal to 2 over 2x plus 1 all the cube meter per second squared towards O. So we take x this direction, we should take any quantity along the increasing direction of x positive, but they are saying it's towards O means it must be minus, it should be a negative quantity. Okay, so at t equals 0, P passes O. So when t equals 0, the particle P is here. So when t equals 0, it is at P with speed 1 meter per second. So here the speed is 1 meter per second. Here the speed is given v meter per second in this direction. Here the speed is 1 meter per second. This direction 1. Diagram clear, no? It's 1 meter per second here. At t equal 0, right. So when t equals 0, it was at O and its speed is 1 meter per second. So that means I can say when t equals 0, x equals 0. First part, find v in terms of x. Very simple, because we know the acceleration, we'll integrate it, acceleration. So we know x double dot, A part, x double dot equal minus 2 over 2x plus 1 all the cube. So x double dot means you know that dx dot over dt2 or dv over dt, dv over dt. That is, we can say v dv over dx is x double dot is equal to v dv over dt. That could be written as dv over dx into dx over dt. Dx over dt is v, so we can write x double dot as v dv over dx. So v dv over dx equal to minus 2 over 2x plus 1 all the cube. Okay, so that clearly shows we are going to integrate to get a relationship between v and x. Don't put a limit, I told in my previous paper also. If you put a limit, you will end up with a value, but you can put limit, no problem. The variables also can be put as a limit, doesn't matter. You can put even do it with a constant. Okay, so if you integrate, it's going to be integral v dv is equal to minus 2 integral dx over 2x plus 1 all the cube. Okay, so this integration you can do by substitution. That is, substitution you can do like this. You can make a substitution, that is let 2x plus 1 as capital X. Then you can differentiate dx over dx is equal to 2. So dx is equal to half dx and so on. You can continue like this. Or better remember, if you have a integration this format, you can continue with this. So here instead of 2x plus 3 all the cube, you can put x cube. Instead of dx, you can put half dx. So x cube will go up, it will become x to the power minus 3, and it will be an integrator. I'll continue it if you want, so that you can say integral of dx over 2x plus 1 all the cube could be written as, instead of dx, half dx, capital Dx, over 2x plus 1, 2x plus 1x, so x cube integral. So now it's going to be half integral x to the power minus 3 dx. So that's going to be half integral of x squared minus 3 plus 1 x squared. So x to the power minus 2, x to the power minus 2 over minus 2 is it? And you can proceed. Then you get 2 minus 2 into 4x squared, that means it will become minus 1/4 of 1 over x squared. Instead of x squared, you can substitute 2x plus 1 on x squared. Anyway, you can do this way, or you can remember the standard format. If it is in this pattern, say for example, if you have an integral of dx over ax plus b to the power n, here n is 3, a is 2. You can integrate that as ax plus b to the power minus n dx. This integration will be at plus 1, so that will become minus n plus 1, that will become the denominator, so that will become denominator minus n plus 1. And remember, if we differentiate it, you will get a, so that a also will come here. Then it will become minus n plus 1, so that is when it comes down, it will become ax plus b n minus 1, 1. So if you differentiate, you will get this one right. Okay, so if I use this standard, remember this standard pattern of integration. So if I integrate that way, it's going to be, this minus 2 will be there, minus n plus 1. So minus n plus 1 means minus 3 plus 2. That means it's going to be 1 over minus 3 plus 1. So that is minus 2. A means 2. 2x plus 1. N minus 1, that is squared, plus c. So that's going to be v squared by 2. Check it. So it will become v squared by 2, I'll continue here, v squared by 2 equal minus 2, this minus 2, yes, this minus 2 here. Minus 2 into minus 2, that will get cancelled. So 1 over 2 into 2x plus 1 squared plus c. Okay, so we need to find the c. To find the c, we can use this substitution. That is, when x equals 0, that is initially when the particle was at O, x equals 0, the speed 1 meter per second, that's given in the question, x equals 0. That means we can say when x equal 0, the speed v equal 1 meter per second. So substitute. So substitute 1 over 2 half is equal to x equals 0. If you put sub 0, it will become 0. Plus 1 is plus 1 squared. So that is half plus c. From this c is equal to 0. So the equation is going to be v squared by 2 is going to be 1 over 2 into 2x plus 1 all the square. 2 will get cancelled. If you take the square root, final equation v is equal to 1 over 2x plus 1. That's the relationship between speed and x, p and x. That's the question, first part. Okay, B part, show that x equal half some expression is given. So that means we need to get a relationship between x and t. Okay, that we can get from the expression what we got now from v, right? From that, we know that B part, we got v equal 1 over 2x plus 1. V means dx over dt equal 1 over 2x plus 1. So integral of 2x plus 1 dx is equal to integral of dt. Here also we can say we can get an expression, so we can put c, or limits also we can put constant later when I finish integration. The limit, the constant to find, I can say x equals 0. So when the particle was here, x equals 0, t equals 0. From that we can find the constant. So we'll integrate it first. It will become 2x squared by 2 plus x equal to t plus c. So we know that when t equals 0, x equals 0, substitute x equal t equals 0, x equals 0 means c equals 0. Okay, so from that you will get it x squared, so I'll write here 2x squared, 2x squared by 2x squared plus x equal to t, that is x squared plus x minus t equals 0. So anyway, t could be variable with x can vary, but it's a quadratic equation like that. So we can get the we can find the x in terms of t by using this standard format. Ax squared plus ex plus c equals 0 means we know that x equal minus b plus or minus square root of b squared minus 4ac over 2a. So by using this we can find the x in terms of t. So that means x is equal to minus b, that is minus 1 plus or minus square root of b squared. So that is 1 minus 4, a is 1 into c minus t over 2a, that is 2 into 1. Okay, so this is minus 1 plus or minus square root of 1 plus minus minus plus minus 1 plus 4t over 2. We know that x is a positive direction, x is a positive quantity, so this minus won't come, so that is going to be minus 1 plus square root of 1 plus 4t over 2. Okay, so this we can write separately, that this 2 means it's a half, that is x is equal to half. We can write the half, common half. This portion first within brackets, square root of 1 plus 40 or 40 plus 1, yeah, 40 plus 1, that's the way it says, 40 plus 1, that in a bracket, this minus 1, minus 1. That's the relationship between x and t. Okay, question 4. It's related to center of mass. A uniform solid hemisphere H has radius r and center O. So I drew the diagram. So this is center O and the radius r. So this is r. Show that the center of mass of H is 3r by 8 from O. Okay, it's a standard question. So we need to ask you, we are going to use x bar equals sigma mi over sigma mi. So that's a standard equation. For that we need to imagine we can fill this solid hemisphere by arranging several solid discs inside. So a particular disc we'll consider inside. So the disc if I consider like this at a distance x from it, so this disc has a height or thickness dx. Its center is O dash. It is at a distance x from O. It's at a distance x from O. And the radius of this disc, let it be r dash. This radius, let it be r dash. Okay, so if I draw a line from O, the center, that is O, to this circumference, that will be equal to r, because any line that is drawn from the center of the hemisphere to its circumference will be equal to r. So this is equal to r. So r dash is the radius of the disc I imagine inside the hemisphere. The volume of the disc delta V is equal to pi r dash squared. R dash is the radius, pi r dash squared into height, the thickness is dx. But what's the relationship with r dash and the distance of the disc from O? You know, in this right angle triangle, r dash squared is equal to r squared minus x squared. Is it in this right angle triangle according to Pythagoras theorem? O dash and this point, the circumference point, if you consider. From that I can say r dash squared is equal to r squared minus x squared. So substitute there. So delta v is equal to pi r squared minus x squared dx. That is the delta v. Okay, so if I take the mass per unit mass per unit volume rho, so the mass of the disk delta m, or I can call it mi, the mass of that particular disk mi is equal to volume delta v into rho. So it's going to be pi r squared minus x squared dx rho. That's the mass of that particular disk, ith disk, at distance x from it. So I can fill this whole hemisphere such that several disks from O to the top. So I'm going to use the equation. The center of mass of this disk is at O at a distance x. So the center of mass of the disk from O is x. Center of mass of the disk from O is x. So I'm going to use the equation x bar, that's the total, that's the center of mass of the hemisphere, is equal to sigma mi xi over sigma mi. Sigma mi means if I add several disks, their mass of several disks, that will be the sigma mi. But we know that that is the total mass. If I fill this hemisphere by several disks from O to the top, then that will be the total mass of the hemisphere. So I can say sigma mi is the total mass of the hemisphere. Total mass of the hemisphere means volume of the hemisphere into density. Volume of the hemisphere is 2 by 3, that's given in the question, 2 by 3 pi r cube, 2 by 3 pi r cube rho, that is the sigma mi. I can substitute finally. So mi xi, so mi is the mass of this particular disk, xi is the distance of the center of mass of that disk from O, that is x. So I can substitute this one finally. So sigma, I'll do the numerator, sigma mi xi is equal to sigma pi r squared minus x squared dx rho into x. X is the distance of the xi. Xi means x here because distance of the center of mass of the disk from O is x. Okay, so there's a function of x with summation. Sigma means it will be integration. So it's going to be this, I'm finding this numerator first, then divide by this one to find the x bar. So it's going to be, I can take pi rho outside. So pi rho integral of r squared minus x squared x dx. The range from 0 to this range 0 to r. 0 to r. Is it? R is the radius. So it's going to be pi rho. If we integrate it, r into x dx, that is r x squared by 2 minus x cube, x to the power 4, because if I separately write it, so that is r squared x dx minus x cube dx. Integral from 0 to r. Okay, so that's going to be pi rho. I can take the dx out, so okay, separately write minus 0 to r, pi rho common. Okay. Okay, so that's going to be pi rho r squared times x squared by 2 limits 0 to r minus x to the power 4 by 4 limit 0 to r. So pi rho, it's going to be r squared means r to the power 4 by 2 minus r to the power 4 by 4 0, 0 will get that 0 when you substitute it will become 0. Here also it will become 0. So when you solve it will become pi rho LCM 4, that is 2r to the power 4 minus r 2r to the power 4. R to the power 4 by 2. Yes, it's going to be, yeah, r to the power 4 it will become pi rho r to the power 4. Yeah, pi rho r to the power 4 over 4. That is sigma mi xi. Okay, I'll erase this. So x bar is going to be sigma mi xi over sigma mi. Sigma mi xi, we found it pi rho r to the power 4 over 4. Sigma mi 2 by 3 pi r cube rho. Okay, pi rho will get cancelled. R cube, r to the power 4. So r 3 will go up, 2 will come out. So finally 3r over 8. That's the final answer. 3r by 8 is the distance of center of mass of the hemisphere from O. Okay, so B part, question number 4. This diagram is given. A uniform solid S, so this is the uniform solid S, shown in the diagram is formed by attaching a uniform solid right circular cylinder of height h and a radius r. So the radius of the cylinder is also r to h. H is the hemisphere. So that one end of the cylinder coincides with the plane face of the H. H is the hemisphere. We already found the center of mass from the flat surface, the base. The point A is the point on H. Point A is the point on H. H is the hemisphere. Such that OA equal to R. So we know that it's not given actually, not necessary to give, because we know O is the center, it's the hemisphere, means this is the radius, that is R. OA is perpendicular to the plane face H. So plane face H, OA is perpendicular to the plane face H. Okay. Show that the distance of center of mass of S. S means the whole body, this shape is called S. Center of mass of S from A, they are giving an expression 5r squared plus 12r at 6h squared. Something we have to show that. Okay. Again, we are going to use sigma mi xi over sigma mi. Okay, so here we can say this solid object S is made of two different solid objects. The solid object S is made of two different solid objects. What are they? Hemisphere and the solid cylinder. Okay, so when we consider x bar of this solid object, x bar x bar is equal to sigma mi xi over sigma mi. Sigma mi is the total mass of the system S that we are considering. So that is going to be the total mass of this one. This sigma mi means the total mass of this one. Both are made of same material. That is not mentioned, but we have to take that way. Both are made of same material. So the density is the rho. So we know the volume of the hemisphere given 2 by 3 pi r cube into rho is the mass of the hemisphere. For the solid cylinder, we know the volume pi r squared h, pi r squared. Pi r squared is the area of the circular portion. Pi r squared into h is the volume of the cylinder into density. So we can find the total mass of S as mass of hemisphere plus mass of the solid cylinder. So that is going to be the sigma mi. Now here sigma mi xi, mi into xi. So that means mass of one particular, there are two objects involved. I told this S is made of two different objects, hemisphere and the cylinder. We are going to find from A the center of mass of S. So if we consider from center of mass of, from A, the center of mass of the hemisphere, from here we found it 3A over R. 3A sorry, 3r by 8, sorry, 3r by 8 we found it from O in the first part. So from O, 3r by 8 means from A, how much is it? This is r minus 3r by 8, that is 5r by 8 is the distance of center of mass of hemisphere from A, 5r by 8. So sigma mi xi means, so this numerator will become sigma mi, mass of the hemisphere into distance of the center of mass of the hemisphere from A. Distance of the center of mass of the hemisphere from A, that is r minus 3r by 8 means 5r by 8 plus mass of the cylinder, we are going to find it, pi r squared h, yes, into rho, into distance of center of mass of the cylinder. So we know the height is h means center of mass of the cylinder from its base is h by 2. It's a uniform cylinder, so the center of mass of the cylinder from the base is h by 2. But we have to find from A, so that means h by 2 plus r. Is it r plus h by 2? So mass of the cylinder into r plus h by 2 over sigma mi. Sigma mi means mass of the S. S we know, I told that already how to find it. Mass of the cylinder plus mass of the hemisphere. If we add it, we'll get mass of the S. That's all. We solved it. We'll get the final, that expression. Simple. Okay, I'm going to do that now. So step by step, we'll find it one by one. So okay, so mass of the hemisphere mh is equal to mass of the hemisphere mh is equal to 2 by 3 pi r cube rho. Mass of the cylinder is equal to pi r squared h rho. The total mass of the S, that is mass of S, that is mass of S is equal to mass of H plus mass of C, that is 2 by 3 pi r cube rho plus pi r squared h rho. So we can take pi r squared rho common. If I take it, pi r squared, yes, pi r squared rho, then it will become 2 by 3 r plus h. Okay, so that is the mass of the S. Okay, so finally we are going to use sigma mi x in that format. So x, that is ms x bar is equal to mass of the cylinder into distance of the cylinder, mass of the cylinder into distance of the center of mass of the cylinder from A. So center of mass of the cylinder is h by 2, that is from O at h by 2, from A means r plus h by 2, r plus h by 2 plus mass of the hemisphere. We found it from O, that is 3r by 8, from O 3r by 8. This is r, so from A, r minus 3r by 8, that is 5r by 8. Okay, substitute everything, you will get the answer. Mass of S, that is pi r squared rho 2 by 3r plus h into x bar. We need to find the x bar finally. Mass of the cylinder, pi r squared h, pi r squared rho h. So pi r squared rho, I put it together to get cancel all. Pi r squared rho into h, r plus h by 2 plus mass of hemisphere. Here also pi r squared rho, so pi r cube rho, pi r cube rho into 2 by 3 times the center of mass 5r by 8. Okay, so pi r squared rho, here also pi r squared rho will get cancelled. We'll solve that one first. So you will get 2r by 3 plus h x bar is equal to pi r squared get cancelled, h into r plus h by 2 plus pi r squared rho, then r 2r by 3 into 5r by 8. Yeah, so pi r squared rho, it cancels with all those things, so that remaining is r into 2r by 3 into 5r by 8, so that is 10r squared over 24. That we can write 5r squared over 12. Okay, so we'll multiply the whole equation by 12 if you want, or we can take the LCM here. Oh, yeah, that's easy, no? If you multiply the whole equation by 12, then it will become 8r. If I multiply the whole equation by 12, then this 12 is easy to solve. We'll see that later. Yes, that way we can solve it. Anyway, it's going to be, you have to solve it now. You can solve this here, 2r plus 3h over 3 x bar equal hr plus hr plus h squared by 2 plus 5r squared over 12. Yeah, better to multiply by 12. So we multiply by 12, so it will be 4, so 4 into 2, 8r, 4 into 3, 12h. X, but you can see that 8r plus 12h is the denominator coming now, equal to, if you multiply by 12, so 12 hr plus 6h squared plus 5r squared. Is it? Am I right? Right, no? Yes, now that's all. Finally, we have with the answer. So x bar is equal to, we multiply the whole equation by 12. So we'll write 5r squared first, 5r squared plus 12 hr plus 6h squared divided by 8r plus 12h. You got the answer. That's all. That's the thing they asked to show that. That's the center of mass of the S from A. From A. This is from A. Okay, part C, the same question, part C, it says that the solid S can rest in equilibrium on the horizontal plane with any point of the curved surface, any point of the curved surface, this is a curved surface, any point of the curved surface of the hemisphere in contact with the plane. Okay, so that means wherever you keep it stays. Say for example, difficult to draw, but I'll try to draw. If you keep it something like this way, small diagram maybe, if you try to keep it like this also, in contact, so it will stay like this at an angle. If you keep it like this also, it will stay. Or if you keep it like this also, wherever, whatever the shape you keep it, like if you, even if you keep it like this, difficult to draw, but anyway, I'll try to draw. It stays even if you keep it. So the idea is here, difficult to draw, the idea here, the normal reaction will be from the contact point, the weight will be from the center of mass. So wherever you keep it, the weight, the line of action of the normal reaction and the line of action of the weight should be along the same line, then it won't have any further turning effect. If that wants to happen, the condition here again, if it wants to stay at rest on any curved part of the hemisphere, the condition is the line of action of the normal reaction from the flow, the horizontal flow, and the line of action of the weight should be along the same vertical line. But we know that this is a hemisphere, this is the tangent, any line perpendicular to the tangent will pass through the center. of the hemisphere. So that means the normal reaction will pass through the center wherever you keep it. The normal reaction from the flow, which is going to be a tangent to the curved part. If you draw a perpendicular line to the tangent to the curved part, it will pass through the center. Simple geometry. So the normal reaction will pass through the center of the hemisphere. Difficult to draw, but I'll try to draw. It will pass through the center of the hemisphere. So the line of action of the weight also should pass through the same vertical line of normal reaction. Means the center of mass of the S should be at O. I hope I understood the condition here. If when you keep it anywhere, if it stays at rest at any point of the curved surface, means the normal reaction from the flow, which is going to be perpendicular to the curve, means it will pass through the center of the hemisphere. It's a line drawn perpendicular to the tangent. So that line of action of the normal reaction and the line of action of the weight should be exactly the same line. That means the weight must act at O. Weight must act at O. Means center of mass of S must be at O. Center of mass of the S is at O, means from A we found an expression for the center of mass. X bar equal this much. X bar must be equal to the radius of the hemisphere, because center of mass must be at O. Simple. So that's the final approach. We are going to do that. So C part, since it's pass and take rest at any curved surface, means X bar must be equal to R. Therefore 5R squared plus 12RH plus 6H squared over 8R plus 12H, that is X bar, that must be equal to R, because from A, the center of mass of the whole S must be at O. Then only the normal reaction will pass through O. Certainly it will pass through O when you keep the curved hemisphere anywhere. The normal reaction will pass through O, certainly. But weight also should pass through the same line, means the weight must act at O. At O means the center of mass should be at O, means from A at distance R. Okay, solve it. So cross multiply 5R squared plus 12RH plus 6H squared is equal to 8R squared plus 12RH. So 12RH will get cancelled. 5R squared, 8R squared. So 6H squared equal, take this 5R squared, then 3R squared. So this is 2. So R is going to be H root 2. The question is find R in terms of H, means R equal H root 2. That's the final answer. Okay, question number 5, circular motion. This diagram is given. A particle P of mass m is attached to one end of a light inextensible string of length A. The other end of the string is attached to a fixed point O. The particle P is held at rest vertically below O. So it's vertically, the string is hanging with a string taut as shown in figure. The particle is then projected horizontally with a speed u. So it's thrown like this horizontally at the lowest point, where u greater than square root of 2 ag. Air resistance negligible. At the instant when the string makes an angle theta with upward vertical, so it's moving, so the part is going to move on a circular path. Upward vertical means something like this. This is O, so the particle is moving on a circular path projected from the bottom. So if this is the O, initially the particle was here. So if it makes an angle theta with upwards O means somewhere here like this. This is theta. Particle is here. So it was projected here with speed u. So when it makes an angle upward O, its speed is v. So the speed is v. And they are saying the string goes slack. The string goes slack means the tension becomes equal to 0. Tension becomes equal to 0. The question is, show that 3v squared equal u squared minus 2ag. So that's what we need to draw, where we need to derive and get it. So upward slide with that, when it makes t, there is speed, but the tension becomes 0. So we are going to get equations for both speed when the string makes an angle theta with upward vertical. Normally we get speed for vertical circular motion by using energy equation where it moves from here to here. Loss in GPE, loss in kinetic energy equal gain in GPE. So gain in GPE means it has gone up. How much it moved up? So the radius is A. So how much it moved up from here means this height. So this vertical height anyway it has gone up from the initial person, which is equal to A plus this height. This height is how much? This is A, this length is A, this is theta means this is theta. So in this right angle triangle A cos theta. So the vertical height is moved from the lowest position to the point where it makes an angle theta with vertical line. The vertical displacement H is equal to A plus A cos theta. That is H. Okay, so that is by using the relationship between speed, conservation of energy, loss in K equal gain in GPE, or loss in kinetic energy is gain in GP, we can get a relationship in terms of V, U and theta with A also. Then we'll get an expression for equation for tension. When it is at this position, tension becomes 0. We'll get an equation for tension. Resultant force towards the center of the circular path is equal to mv squared over. From that, we substitute t equals 0 because they are saying string is sagging means it's t equals 0. By substituting t equals 0, we can get that relationship what they asked to show. So I'll raise this diagram and going to draw this here. Okay, so we can use the height h, we have to find it. So if I say this is the height h, that is equal to A plus this is A cos theta, so this is theta means this is also theta. So this is A cos theta, this is A, this is same length as the radius. So h is equal to, the height it moved up is equal to A plus A cos theta. So the relationship that we can get between initial speed and final speed, we can say loss in kinetic energy equal gain in gravitational potential. And loss in kinetic energy half mu squared minus half mv squared equal to mg. H means A into 1 plus cos theta. So we divide all the whole equation by m and multiply by 2. So u squared minus v squared is equal to 2ga into 1 plus cos theta. Okay, so then for the tension, the centripetal force towards the center of the circular path is the centripetal resultant force towards the center of the circular path is the centripetal force. At this position, if I draw the forces acting on the particle, the actual forces, weight is acting vertically down, tension is towards the center, this angle theta, so the speed is v. So resultant force towards the center of the circular path is the centripetal force. So that is towards the center of the circular path, F equal T plus mg cos theta equal mr omega squared, mr omega squared. So mr omega squared or we can say mv squared over mr omega squared or mv squared over r means here a, mv squared over a. Okay, so that t is equal to 0. They are saying, okay, I'll substitute this t plus mg cos theta equal m over a v squared. And so v squared we can substitute u squared minus, so v squared I can say u squared minus 2ga minus 2ga cos theta. Yeah, we need to eliminate eliminate the cos theta here because the answer is given in terms of v squared. So we need to keep the v squared here. Okay, so when t becomes 0, when the string slacks, t is equal to 0. So mg cos theta t equals 0 means t becomes 0. So mg cos theta equal m v squared over a. So m will get cancelled. So g cos theta, or you can multiply ag cos theta equal v squared. Okay, let it be equation 2. This one equation 1. Okay, so from the equation 1, u squared minus v squared is equal to, multiply inside, 2ga plus 2ga cos theta. So that's going to be 2ga plus 2ga cos theta. Ga cos theta equal v squared, u squared minus v squared. So solve it. So bring it to the right. So u squared equal to, they also show it in terms of v squared as a subject. So u squared, bring it to the left, minus 2ga is equal to, take that 3v squared, that is 3v squared equal u squared minus 2ga. That's the thing they also show. Earlier I tried to eliminate v squared. No, we have to eliminate cos theta because the answer does not have cos theta. So anyway, depending on the question, we have to do it. We eliminate the cos theta by finding an expression for mg cos theta in terms of v squared by substituting t equals 0, because when the string slacks, t becomes 0. To GA, the question paper said to AG, whatever it is, AG or GA, the same. Okay, we need these two equations for the B part later to eliminate certain things. This expression, equation u squared minus v squared 2ag cos theta, so I wrote it again just for the B part to use it. And the final expression what we got. We need this for B part. So in B part they are saying from the instant when the string goes slack to the instant when OP is next horizontal. So at this position the string slacks. So when the string slacks, what happened? It won't follow a circular motion. The reason when the string slacks in vertical circular motion means the particle has no intention of moving away from the center. That means there is no centrifugal effect. So but it has speed. The speed is not equal to 0. The speed is non-zero value, but the tension becomes 0. That means the particle is not following a circular path, because if it is following a circular path, the particle will have centrifugal effect. It will move away from, it has intention of moving away from the center, so it will stretch the string. There will be tension, but they are saying there is no tension. So what's going to happen? No tension, no circular motion, but speed is non-zero value. What's going to happen? The particle will follow a projectile path. It will move on a projectile motion. So if it is moving on a projectile motion, this is the speed at that moment. So it's follow a projectile motion, something like this. Is it? The question says, from the instant when the string goes slack to the instant when OP is next horizontal. OP is next horizontal. O refers to center. P is the particle. P is the particle. So the particle becomes horizontal. So the line OP becomes horizontal. That does not mean when it follows a projectile motion path. So I'll erase this word circular motion path. It's going to follow a projectile path and it's coming to horizontal path. Something like this is following a horizontal path. So that does not mean it comes to the same, the distance of the particle. When the particle comes to the same horizontal level, OP, this is the particle, P follow the projectile motion. We don't know whether OP, this length OP is equal to A, we don't know. If it is A, the particle will be under tension, but we don't know whether it has reached. So that's the third part question they are asking. The question is, the particle is following, it's going to follow a projectile path. When the particle comes to the same horizontal level from that line passes through O, the question is, we have to show the time taken for the whole motion is capital T. and theta is 30 degree, at which the tension becomes 0. They are telling theta equal 30. And when the particle comes to the same horizontal line that passes through the O, the time taken is capital T. We have to show T equal to V over G. But careful, don't have a wrong idea. When the P comes to the same horizontal level, does not mean P is at the circumference of the expected circular path. No, we don't know. It might be or not. So that is the C part. The particle has tension. If the particle has, the string has tension means, yes, when it comes to the same horizontal level, the P should be here, that is on the circumference of the circular path, then there will be tension. But we don't know for the second part, we don't know whether it is exactly the horizontal displacement is equal to A. A is the radius of the circular path. We will find it later. That's for the C part. But here we have to find the time taken for the circular motion, projectile motion when it moves from this position to here. So there the theta is given 30 degrees. So this is 30 degree. If this is 30, this will be of 30. What will be the angle of P with horizontal? How it will be? The velocity will be along the tangent. The speed, the velocity is there, but no tension, right? The speed is V. How much will be this angle? So the V will be tangent to the circular path at that moment when the tension becomes 0. Beyond that point, at that point when the angle is 30 degrees, yes, it's on the circular path, but it's not going to follow after that. It's going to follow projectile motion. So at that time, the line that connects to the center and the velocity are perpendicular to each other, because you know when the particle moves on a circular path, the velocity will be along the tangent. So this is 90 degree, this is 30. So this is 30 means this is 60, is it? Because this is horizontal line, this is vertical line. So this is 30 means this is 60, but this is 90 because velocity is perpendicular to the radius. So this is going to be 30. So this angle 30. So at the moment when the particles start to follow projectile motion, the velocity V makes an angle 30 degree with the horizontal line. By using it, we are going to find the time taken. Okay, so we need to get an equation for T, or we have to derive and get an expression for capital T. Capital T is the time taken to move from this point to this point, where this point means the OP becomes horizontal. The time taken is capital T. How much it moved vertically down? So when we consider projectile motion, something like this, a particle is here, projected at an angle, at a speed V, at an angle 30 degree to the horizontal. It followed a projectile path, something like that. It has come to a position here. So this position is here, right? It has come to this position. So what is the vertical displacement when the particle moves from here to here? The time taken is capital T. What will be the vertical displacement? The vertical displacement is this much. This is the vertical displacement downwards. When you consider the time T, initially here, finally here, this point means this point, finally here. The vertical displacement is this much. So the vertical displacement is this much. How much is it? This is A, this is 30 means A cos 30. A cos 30 is the vertical displacement downwards. So we are going to use the equation S equal U for the whole motion, for the projectile motion from here to here. I am going to use downwards S equal UT plus half AT squared. A is the acceleration. Here careful, radius also A, but here A means acceleration. A stands for acceleration. I'll put G because it's moving under gravity, so GT squared. So downward direction from here to here, the vertical displacement, this is the vertical displacement, that is in this right angle triangle. When you consider this A cos 30, that is A cos 30. So S is A cos 30. The U, initial vertical component of the velocity, I took it downward direction, so this is going to be sine 30 upward, so minus V sine 30 into capital T, because the total time taken in the question given capital T, V sine 30 T plus half G T squared. Substitute, cos 30 means root 3 by 2, so root 3 by 2 A equal to sine 30 is half minus half T plus G by 2 T square. Multiply the whole equation by 2, you will get root 3 A. A is outside actually, not inside the root 3. So A equal to minus t plus gt squared. So it's a quadratic equation in terms of t. Gt squared minus t minus a root 3 equal to 0. I think there's a, sorry, the v sine t, no? So there's a half sine, yeah, v is missing, v by 2t, so that is minus vt, minus vt equal my gt squared minus vt minus a root 3 equal to 0. So this v I missed it. Yeah. Okay, so again we are going to use the standard format, you know, the finding the solution of ax squared plus bx plus c equals 0 means x equal minus v plus or minus square root of b squared minus 4ac over 2a, is it? So there, if we consider t is equal to minus b, that is v minus v into v minus v plus or minus square root of b squared means v squared minus 4 a is g, c is minus a root 3 over 2a 2g. Looks very weird, is it? Looks little, we'll see how we are going to solve it. Right. So we'll try that. So t is going to be v plus or minus v squared minus into minus plus 4ag into root 3 over 2g. Okay, but the question, the answer is very simple, t equal 2v over g, but we are not getting that for 2v over g. Okay, so that means we have to eliminate this. For a is unmoded thing, we have to eliminate it because you can see the answer they asked, so 2v over g, so we have to eliminate a and g is there anyway, but anyway I have to eliminate the a part, is it? So that's what I am going to do. For that I am going to use this one again. Okay, so from this I have to eliminate, and we know cos theta equal 30. So from this I am going to get an expression for a. Okay, simple. So here u squared minus v squared 2ag, this we got it, and we know this format. The final answer consists of v, so from here we will eliminate u, right, 2 by substituting theta 30. So from first equation I write it. So how many marks they are giving for this question? Yeah, 4 marks. Okay, so from this u squared minus v squared u squared minus v squared equal 2ag plus 2ag cos theta equal 30, so 2ag plus 2ag cos 30 is root 3 by 2, so you will get 2ag plus 2ag cos 30 root 3 by 2, so root 3 by 2, 2 and 2 get cancelled, we will get root 3ag or ag root 3 is u squared minus v squared. Okay, so from this u squared, instead of this u squared I can substitute 3v squared plus 2ag. Instead of this u squared I can substitute 3v squared plus 2ag instead of u squared. So 3v squared plus 2ag minus v squared equal to 2ag plus ag root 3. We'll see what we are getting finally. So 2ag will get cancelled. 2v squared minus v squared is 3v squared minus 2v squared. So 2v squared equal ag root 3. Okay, so the ag root 3, you can see that ag root 3 is there. ag root 3 is there. Instead of ag root 3, I can put 2v squared in that case. So we will continue that equation. So t is equal to v plus or minus square root of v squared plus, instead of ag root 3, I'll substitute 2v squared. So 2v squared into 4, 8v squared. Now we are getting very simple format 2g. So that is v plus 1 v squared plus 8v squared, 9v squared, square root of 9v squared, that is 3v, is it? V plus or minus 3v over 2g. Okay, so minus we don't take it because time is always positive. So minus means it will become minus 2v over 3g, can't be negative. So we have to take only the positive. If we take positive, v plus 3v, 4v. So that's going to be t is equal to 4v over 2g. So 2v over g. Right, interesting, is it? Okay, so the next part, that's the last part. Hence show that the string goes taut and again when the when it is next horizontal, just 2 marks. That means we'll find the horizontal displacement. We consider the motion from here to here. That means we don't know OP equal to the length OP is equal to radius means yes, there will be tension, is it? Because the same length means there will be tension. We'll find that horizontal displacement. So when it moves from here to here, what is its horizontal displacement totally? That means horizontal displacement means from here to here, from this point to this point. How much will it be? If it is, this is we know A. If it is horizontal displacement, if it is on the circumference of the circle, it should be A. This should be A sine 30. A sine 30 means A by 2. So if the horizontal displacement equal to this length A sine 30, that is A by 2 plus A, that is A by 2 plus A 3A by 2, then the particle P will be on the circumference of the expected circular path, then there will be tension. We'll find the horizontal displacement by using horizontally S equal ut plus half at squared. That is the C part. So we know T equal to V over G. Okay, so we use horizontally S, that is C part now, but then it was B part. Horizontally S equal ut plus half at squared until OP becomes horizontal during the projectile motion. So S is going to be, that is going to be U is V cos 30, initial velocity V cos 30, is it V cos 30 into T, that I can substitute that one, plus horizontally there is no acceleration, we neglect the drag force, so that's going to be V cos 30, substitute cos 30 means root 3 by 2, V root 3 by 2 into, instead of T, 2V over G. Okay, so it's going to be 2 will get cancelled, V squared into root 3 over G. Okay, still we have to do more. Now this V squared, we got it earlier. Yes, earlier when we were solving these two equations to eliminate the square root, when we got that time, we got an expression for V squared. We got that V squared root 3 AG, that we got root 3 AG when we solved it. I don't want to do it again. We got AG root 3 is equal to V squared by 2, we got it. You might remember that. We got AG root 3 is equal to V squared by 2. We got it earlier. So instead of V squared, here we can substitute. So V squared we can substitute 2AG root 3, 2 AG root 3 into root 3 over G. So root G will get cancelled, root 3 into 3. So that's going to be, one minute. So that is 2V squared, root 3 we got earlier, root 3 AG equal 2V squared. So from this V squared is equal to AG by 2 root 3 we can substitute here. So it's a V square we can substitute. AG root 3, AG by 2 root 3, that is V squared, it's a V squared, times root 3 by G. Okay, so G will get 3 into 3, root 3 into root 3, 3. So that is 3A by 2. So 3A by 2 means the length, if you consider from this point to this point, that is going to be, this 3A by 2 means it's going to be the horizontal displacement S is going to be, we got 3A by 2, that is A plus A by 2, A plus A by 2. So this is A plus A by 2. That means the P will be, the particle P will be on the circumference of the circle, circular path. So the particle P will be on the circumference of the circular path. So therefore that string will be under tension, or there will be tension on the string. I can write this A by 2 plus A, that is A by 2 plus A means this is A by 2 if it is on the circumference of the circular path. If it is on the circumference of the circular path, this is A by 2 because A cos 30. If it is on the circumference, it will be A. So A by 2 plus A by 2 plus A, that is 3A by 2. So the particle P will be on the circumference of the circular path. So the string will be under tension. That's the answer we have to give finally. Okay, question number 6. A particle P of mass m is attached to one end of a light elastic spring of natural length 2L. The other end of the spring is attached to a fixed point A. The particle P hangs in equilibrium vertically below A at a point E where AE equals 6. So we'll put a diagram. So initially when the spring is here at its natural length without any particle, its length is 2L. When you attach, this will put A, right. When you attach a mass to the particle, mass m, the length of the string becomes 6L. So that means the extension is 4L, is it? So when you attach a mass, the string becomes here. So this is the mass of the particle is m. So the extension, this extension is 4L. The total length is 6L. So this is 4L. The extension becomes 4L. The extension. This is 2L. Okay. This is E, the name given to the position, that is E. Okay. The particle P is then raised a vertical distance 2L and released from rest. So they are moving it 2L. So that means this is 4L. So this is 2L. This is 4L. Like this we can draw. Right, it's moved up vertically raised up by 2L. That means if I draw something like this, this is the equilibrium position where the particle comes to rest. This is at E. It's raised to a point 2L above it. So this is 2L, they are saying it. This length is 2L upwards from the equilibrium position. Okay, and released. Still it is under extension. Okay, so that's going to be the amplitude when you move it through a particular distance from the equilibrium position release. That is going to be the amplitude of the oscillation. So the amplitude A is equal to 2L. If we can remember that way. From the equilibrium position, if we move a particle and release it, that's going to be the amplitude. Through what distance we move from the equilibrium position will become amplitude during the some oscillation. Show that P moves with simple harmonic motion of period t. Right, okay, so if you want to show it's moving with period t, simple harmonic motion, we need a variable. So anyway, they are moving it through 2L. So during the motion, it is at a distance x from the equilibrium position. Upwards, we will take it. And we are going to get an expression for x double dot and the x. So amplitude is 2L, right? So when it is at this position, we are going to get an expression, right? Okay. For that, nothing is mentioned about the lambda. So for that, we need to get an equation for that. At the equilibrium position, when it is at E, when E is at E, if I draw the forces acting on it, downwards the force is mg. Upwards, lambda over L, the natural length is 2L, into the tension. I'll make that as tension T. The tension T. The T is equal to lambda over natural length 2L into extension, how much? 4L. So that's going to be, T is going to be 2 lambda. E is the equilibrium position. What do you mean by the equilibrium position? Equilibrium position means the point at which the resultant force becomes zero for a simple harmonic oscillator. So at equilibrium position, so that is E. At E, T is equal to mg. Only two forces are T and mg. It's at rest. Then only it was pulled up through 2L and released. So T equal mg at the equilibrium position. So instead of T, I can put 2 lambda equal mg. So from this we can say lambda equal mg by 2. Right. So during the oscillation, I want to get an expression for the simple harmonic motion. So I'm doing the A part of question number 6. So A part of question number 6. This is A part. We'll use F equal mx double dot along the direction of displacement. The displacement is taken upward direction because it was raised up. The resultant forces acting on it are now the new tension T minus mg equal mx double dot. Okay, so what is the tension now? Earlier, when it was at the position E, the extension was 4L. Now it's moved up through x. So the extension is going to be 4L minus x. So T equal lambda, standard equation lambda over L, lambda over 2L, is it lambda over 2L into extension. Extension means now at this position, when it is at E, the extension is 4L. Now it's moved up, so the extension will be reduced by x, so that is 4L minus x minus mg equal mx double dot. Instead of lambda, I can put mg by 2. So mg by 2 means over 4L. Is it by 2? 2 into 2L, 4L into 4L minus x minus mg equal mx double dot. Multiply inside. So 4L, 4L will get cancelled. Mg minus mg over 4L into x minus mg equal mx double dot minus mg will get cancelled minus mg over 4L x equal mx double dot will get cancelled, so we'll get x double dot equal x double dot subject x double dot equal g minus g over 4L into x. G is constant, L is constant, so this is going to be omega squared. So this is in the form of x double dot equal minus omega squared x, where omega squared equal g over 4L because they both g and L are constants. So x double dot directly proportional to minus x, hence simple harmonic motion. Omega is this one. But the question is, we need to find the period. So we know that omega equal 2 pi over t equal 2 pi over omega. So t equal 2 pi over omega square root of g over 4L. So that's going to be 2 pi square root of 4L over g is the time period. Careful, time period t, tension also t, but don't get confused of them. This is different, this is different. So this is the time period of oscillation. Check it, omega equal 4 pi 18. There's a mistake, I think. No, nothing wrong. This 4L, the 4 square root, when it comes out of the square root, it will become 2. When this 4 square root comes out, it will become 2. 2 into 2, 4 pi. He has to show that way, 4 pi into square root of L over G. Okay, that's all. Earlier I showed it, nothing wrong, but the question paper says to show this way, so we are bringing it out. Square root of 4 is 2, 2 into 2, 4. Okay, so B part, find in terms of M, L and G the kinetic energy of P as it passes through E. E is the equilibrium position. So B part, we know that V squared equal omega squared A squared minus X squared is the general equation to relate speed and the X. So E is the equilibrium position, displacement is always measured from the equilibrium position means. So speed at E means x equals 0. We need to find the V when x equals 0, that is the speed at E. So at E, x equal 0, therefore the speed is going to be the maximum because when x becomes 0, the amount of subtracted value is going to be 0, means it's going to be the maximum. So V squared equal A squared omega squared, V is equal to A omega. We need to find the kinetic energy, we'll find the speed, then half mv squared. So V is equal to A omega, or we'll say V squared equal A squared omega squared because we are going to find the kinetic energy. So that is A squared, we know the amplitude. I already told that it's moved through 2L from the equilibrium position means 2L is the amplitude. So A squared is 2L all in squared. Omega squared, we already got the expression for the omega squared, G over 4L. That is V squared. So it's going to be 4L squared. Here 4L squared. 4 will get cancelled. So that's going to be GL. V squared is going to be GL. So 4 will get cancelled. L squared, L, yes, GL. Okay, so kinetic energy at E, that's the question. Kinetic energy at E, that's the equilibrium position, half mv squared, that is half mv squared GL, that is mgl by 2. That's the answer for B part, kinetic energy at E. Okay, so part C, find in terms of capital T. Capital T is the time period. The exact time from the instant when P is released. P was raised to a height, raised to a distance of 2L from the equilibrium position. So that's going to be the amplitude. So from the instant P is released to the instant when P has moved a distance 3L. We'll come to the point. Distance 3L, that's the question. Careful, not displacement. Distance 3L. They are asking Okay, so what will happen when we raise the particle from the equilibrium position through a distance L like this? We draw a diagram. Uh, okay, so this is the equilibrium position. It's raised to a height 2L from the equilibrium position, means that is going to be the amplitude. So this is the amplitude. Amplitude is going to be 2L. So when you release it, it will oscillate in simple harmonic motion about the equilibrium position. This is the equilibrium position. We can name it O, the equilibrium position. It will oscillate up and down with the amplitude 2L. So it will come up to 2L. Here also the downward displacement also will be the amplitude, downward amplitude also will be 2L. It will oscillate between these 2 points in simple harmonic motion. But the question is, we need to find the time taken in terms of capital T period for the part from the instant when P is released from here to the instant when P has moved a distance 3L. Distance 3L means from here to here, if it moves, the distance moved is 2L. Then it should move down a distance L. Then the total distance moved 2L plus L, 3L. So the question is, find the time taken by the particle to move from here. For example, I can name it, say something like P to the position here. This is L, the distance it's moving, or the displacement. I can say the displacement of the particle becomes initially 2L on one side to the L on other side. Careful, 2L on one side to the L on other side. What's the time? So this displacement is L. The distance is from here to here. The distance between P to Q is 3L. Okay, so C part, distance between PQ, distance. P and Q equal 2L plus L, 3L. But displacement, in terms of displacement, this is the equilibrium position, means initially it has a, now displacement means the vector, we have to use the sign. Initially the displacement is 2L, always displacement measured from equilibrium position. Initially displacement is 2L. What will be the time taken to have a displacement minus L? Initial displacement 2L equal 2L, which is upward direction. We'll take upward direction positive. Final displacement minus L, because opposite direction. Displacement means minus. So then total distance travel is 3L, is it? From here we measure the displacement. From here 2L. From here L downward means minus L displacement. Upward direction we take positive. So the total distance moved is 2L plus L, 3L. So we need to find an time for that. We know the equation. X equal, we have two equations. A sin omega t, x equal A cos omega t. Which one are you going to use? X equal A sin omega t. Other one, x equal A cos omega t. We know the initial point is the amplitude. Initially, it is at the maximum displacement position. That is at the amplitude. So, this we use initially. When you put t equals 0, you will get x equals 0 means, x equals 0 means initially the particle is at the equilibrium position. Then, when it has a particular displacement, how long will it take to go to that displacement? For that, we use this equation. Initially, the particle is at the equilibrium position when t equals 0. Later, when it has a particular displacement, what will be the time taken? But that we are not going to use, because particle is not at the equilibrium position. Particle is at the extreme position, where the amplitude. So initially the particle is at the extreme position. So when you put t equals 0, you will get x equal A. A is the amplitude, which is 2L. A equal 2L. Then we are going to find how long will it take to have a displacement of minus L. Minus L. Okay. If I find the time, that is the final answer. So I am going to use x equal A cos omega t. So x is going to be minus L. This is 2L cos omega t. So that's going to be cos omega t is going to be minus 1. Cos omega t minus 1, cos inverse minus 1 pi, you know that 180 degree, but in radians pi. So omega t equal pi. So t equal pi over omega. We know that omega equal 2 pi over t. So t equal 2 pi over omega. T equal 2 pi omega. So pi over omega means t by 2. T by 1 minute. Omega is equal to, sorry, it's 2 pi, I made a mistake. Cos omega t is minus 1 means that is pi, yes, that is pi. This is minus half, not minus 1, that is minus half, yeah. Minus L divided by 2L is minus half. That is minus half. So that is omega t, cos inverse minus half. How much is it? 2 ones, that is cos minus half means that's going to be, that is 2 pi by 3. So t is going to be 2 pi over 3 omega. Okay, so we know that omega equal 2 pi over t. So t is going to be 2 pi over omega. Pi over omega means t by 2. 2 pi omega is, anyway, 2 pi omega t. So 2 pi omega. So 1/3 into 2 pi over omega. That is t by 3, 1/3 of t. That's a time table. Okay, so the time table is 1/3 of the time period. Or you can find like this, what's the time taken to move from P to O. P to O, you can find it separately as T1, that is by using x equal a cos omega t. X you can put 2L and find the time taken to move from P to the equilibrium position. Then how long will it take to move from equilibrium position to L? You can find it again by using x equal a sin omega t. Find it. That is as t2 at the both time you will get it. For example, I am saying if you have confusion of substituting this minus L and those things, that's anyway nothing actually. I made a mistake, this half, I put it as minus 1, it's actually minus half. Yeah, it's a mistake. Anyway, otherwise, this is easy, quickly you can get it. Otherwise, you can find the time taken to move from E to E by using x equal a cos omega t, because initially at the extreme position, then it's moving from extreme position where amplitude is 2L to the equilibrium position. First, find it by using x equal a cos omega t, x put it 2L, find the time t1. Then from equilibrium position to this, for that you can put x equal a sin omega t. From equilibrium position to this position, x equal a sin omega t, x substitute L, just put L, don't put minus L, because minus L we put when we compare when the motion happens from one side to other side, continuously, from one side to other side continuously. When we consider the motion, we have to put minus L and amplitude L. But if we take part by part, the time taken move from here to here, we don't think about the other motion. From here to here, we can use x equal a cos omega t, x equal L, find the time. Then from here to here, we don't need to consider, because we are considering from equilibrium position to a particular position. So we are not defining positive negative when we consider from equilibrium to one side. But when we consider the motion from one side of the equilibrium position to other side of the equilibrium position, we must include positive negative, because one side of the equilibrium position, if we take it positive, other side of the equilibrium position should be taken negative. Okay, so that's the reason here minus L is come. If you are taking part by part, from here to here, x equal a cos omega t, x equal, just put positive 2L, find the time t1. Then from here to here, x equal a sin omega t, x substitute just L, don't put minus L, just L, find the time t2. At that both time, you will get the same answer. Okay, try that way also. The minus sign comes when we consider the motion from one side of the equilibrium position to other side directly. So I am using this equation directly for the motion from P to Q. So both are on either side of the equilibrium position. So we have to consider the minus sign. Okay, question number 7. This diagram is given. A particle P of mass m So this is the particle P of mass m is attached to one end of a light elastic string of natural length A. So the natural length L equal A. And modulus of elasticity, that is lambda equal to mj. The other end of the string is attached to fixed point O on a rough plane. So there will be friction when the particle moves, which is inclined to horizontal at an angle alpha. The particle P is held at rest on the plane at point A, where OA equal A. That means this distance is natural length, equal to the natural length, as shown in the figure 5. The particle P is released from A and slides down the plane, coming to rest at the point B. So somewhere here the particle is coming to rest. The coefficient of friction of between P and the plane is mu, which is less than tan alpha. Air resistance negligible. A part show that AB means the distance it moved from the point where it was released to the point where it comes to rest. B, right? AB equal A into sin alpha minus mu cos alpha. Okay, so this question can be done in two different ways. One by using energy equations, the other one by using Newton's second law, F equal mx double dot. I'll do the both methods. Okay, first method, method 1. I'll use the energy equation. So when it moves down, it's losing the gravitational potential energy. The speed is increasing actually until certain point. So what happens when it moves down? At the moment you release, we'll analyze that way. When the particle is released, at that moment it has component of the weight along the plane down, which is mg sin alpha. In my previous papers I already discussed it. The component of the weight along the plane down is mg sin alpha. If this angle slope is alpha, the component of the weight along the plane down is mg sin alpha. Component of the weight perpendicular to the slope, that is mg cos alpha. So there's a force mg sin alpha. So when the particle moves down, there will be friction acting on it. The friction acting on it, that is constant mu r. So r equal mg cos alpha, because the normal reaction r, the weight component perpendicular to slope is mg cos alpha. There is no motion perpendicular to the slope, means r must be equal to mg cos alpha. The friction is given by F equal mu r, but r equal mg cos alpha, therefore mu into mg cos alpha, that is the friction. Okay, that we don't need these two forces, we don't need to consider. So when it moves down, there will be friction acting. Also, there will be tension due to the extension of the string. Okay, so what happened when the particle moves down? Mg sin alpha constant, friction constant, but tension depends on the extension. So when the particle moves down, the resultant force is going to decrease, because the resultant force along the slope will be mg sin alpha minus mu r, that is the friction, F equal mu r, instead of r I can put mg cos alpha, minus tension, which is lambda over L, the natural length anyway given as A. I'll put the standard equation, lambda over L into extension x. So it was initially at the point where the length of the string is same as the point where the particle was at rest. So when it moves down, x is going to increase from 0. So this quantity remains constant, this quantity remains constant, this will increase, means the portion which is subtracted will increase. So the downward acceleration will decrease, or the downward resultant force will decrease. Initially, at the moment it was released, x equals 0, and at the moment release, friction also not there. When it starts to move, there will be friction, but extension will increase when it moves further down. Anyway, this quantity mg sin alpha minus mu r remain constant. When x increases, the downward resultant force will decrease. There will be a point at which f becomes equal to 0, resultant force becomes 0. Until that, the particle will accelerate because of the resultant force. That we need to use for the second part. Actually, they ask you to find the maximum speed, that is, we'll use in the second part, that idea. So the particle will accelerate down, or the kinetic energy of the particle will increase until the resultant force along the plane down becomes equal to 0. Until that, the speed will increase or the kinetic energy of the particle will increase, at which when the F becomes 0, at that moment it will have the maximum speed. We are going to use that idea for the second B part. They asked to find the maximum speed. I'll use that idea. Okay, so beyond that, what will happen? At the moment when the F becomes equal to 0, the speed is not equal to 0. It has a real positive value because it's already accelerated along the plane now. So the speed is not equal to 0. So even when the force, the resultant force at a momentarily becomes or instantaneously becomes equal to 0, the speed is there. So the particle will move further down. When the particle moves further down, x is going to increase further. Now this portion is going to increase further. Earlier, at the point where the resultant force becomes equal to 0, this portion balanced this part. Now this is going to increase further, means the resultant force is going to be upward direction because of this is increasing beyond that value. So the resultant force will be upward direction. Particle will move downward, means the particle will decelerate. So when a particle decelerates continuously, there will be a point at which the particle will come to rest in momentarily or instantaneously. That point is the B. So actually what happened when we think about in terms of energy equation, for the motion from A to B, B is the point at which it's coming to rest. It gained kinetic energy during the motion, but whatever the kinetic energy it gained, again lost in the form of again work done against friction and gain in elastic potential energy. So when we consider the motion from A to B, the particle is not gaining any kinetic energy because at A it is at rest, at B also it is at rest. So whatever the kinetic energy it gained during the motion, but whatever the kinetic energy it gained, again it lost because of further motion downwards. Finally, the energy which when it moves to the down to the bottom point where it comes to rest, all the loss in GP will become equal to work done against friction and elastic potential energy. So when during the motion it's losing the losing the gravitational potential energy because it's doing work against friction during the motion, and the elastic string is stretched, it's gaining elastic potential energy, kinetic energy initially and finally 0, so there is neither, not gain, not lost, is it? So the energy equation what we are going to write for the motion from A to B, we can write loss in gravitational potential energy equal to gain in elastic potential energy plus work done against friction. I think it's better to start there up. That's easy. So for the motion from A to B, first method, A part, first method, loss in gravitational potential energy equal gain in elastic potential energy plus work done against friction So there is no gain in kinetic energy, no loss in kinetic. It gained kinetic energy but it lost. So finally neither, not gain, not lost anything. Loss in GP. So the distance it moved from A to B, let that distance be D. Easy to note it down. D, the point A. This is point B. So let it be D. Loss in GP, the vertical height it moved mg d sine alpha. Is it loss in GP? Mg d sine alpha. Gain in kinetic energy. Gain in elastic potential half lambda over L, you know that elastic potential energy, lambda over L into x squared. That's a general equation for the elastic potential energy. Initially there is no elastic potential energy. Gain in elastic potential energy means final elastic potential energy minus initial elastic potential energy. Initially there is no elastic potential energy because no extension. So lambda half into lambda over L into x squared. So lambda we know that, okay, I'll write that minus 0. Initially there is no elastic potential. I'll substitute later. Plus work against friction Fr into the distance mode. But we know that friction Fr is equal to mu r. I already told that r is equal to mg cos alpha, the component of the wave perpendicular to the plane. So mu r equal mg cos alpha. So we lose those things here. So it's going to be mg d sin alpha equal to half lambda equal to mg over L a x squared, that is d squared. Is it x squared means d squared, plus friction, that is mu mg cos alpha into d. Okay, so d squared d, I can divide the whole equation by d. M I can divide the whole equation by m, and also I'll multiply the whole equation by 2a. Okay, so we'll 2a, not necessary, half and 2 will get cancelled, so that won't be there. So 2 and half get cancelled. I'll multiply the whole equation by a. Again, I'm telling it, I'll multiply the whole equation by a. I'll divide the whole equation by m, and also I can divide the whole equation by d. So d squared d. So I can divide the whole equation by d. Okay, so so that means it will become g sin alpha. Is it m got cancelled? G sin alpha equal to 2 and 2 get cancelled. G d over a plus m got cancelled, mu g cos alpha. Multiply the whole equation by a. So a g sin alpha equal to g. Okay, I can divide the whole equation by g also. The whole equation will divide by g also. So a sin alpha is equal to g got cancelled, d plus mu a cos alpha. So d is equal to a sin alpha minus mu a cos alpha. So we can take the a out. Yes, a out of that. Sin alpha minus mu cos alpha. That is d. D means AB. Okay, so I got it by using energy equations. Okay, so method 2a part, there I am going to use Newton's second law. So if I consider the forces acting on the particle along the plane downwards, mg sin F equal mx double dot we are going to use. So along the plane down, the forces acting on it, mg sin alpha, that's along the plane down. I'm taking along the plane down because when we use, we know we have to integrate it. So along the direction of motion, or from A, we are going to measure the displacement x. So that displacement x we are going to consider from point A. So we should take along the direction of displacement positive. So mg sin alpha, that is along the plane downwards. When we consider the friction that is acting upward direction, F equal mu r. R is the normal reaction to the plane, but R equal mg cos alpha. So that's going to be mu mg cos alpha. Then friction F equal mu r. Then the tension T is equal to lambda over L into x. Lambda given as 2 mg. L is given as A. The extension is a variable because when the particle moves down, the extension is going to change. So that will be given as tension 2 mg over A x. That is equal to m x double dot. We know that x double dot b dv over dx. Okay, we can divide the whole equation by m. So it's going to be g sin alpha minus mu g cos alpha minus 2g over a x equal v dv over dx. Okay, so that shows clearly we are going to integrate, we have to integrate. So it's going to be g sine alpha integral dx. I'll tell you the limits now. Wait. Minus mu g cos alpha integral dx minus 2g over a 2g over a integral x dx equal integral v dv. Okay, so here the limit for v, initially the speed was at, the particle was at rest, it was released from rest. So the initial speed is 0. When the initial speed is 0, x is 0, because it's released from A where there is no displacement, no extension. When the particle reaches the point B where it comes to rest, the speed becomes 0 again. That time, we are going to find the distance moved along the plane. So we'll take AB, the length it's moving from A to B as d. So we are going to integrate x from 0 to d, 0 to d. Okay, we'll continue now. G sine alpha. So d means the distance AB. I put it as d rather than putting AB. Yeah. So g sine alpha x, the limit 0 to d, minus mu g cos alpha limits x, that is 0 to d, minus 2g over a x squared by 2, this 2 and this 2 will get cancelled, anyway 0 to d equal 0, because v squared by 2, if you substitute 0 0, anyway 0, I put the 0 now itself. Okay, we'll continue. So g d sine alpha, when you put 0, anyway x will become 0, so I don't need to consider these values, minus mu g d cos alpha minus 2 and 2 will get cancelled, d squared over a equal to 0. Okay, so sorry, gd squared over a, that's g also, g d squared over a equals 0. So I can divide the whole equation by g, or I can divide the whole equation by d, divide the whole equation by g, and multiply it by a. So you will get divide by, I can say gd. So if you divide by gd, a sine alpha minus mu a cos alpha is minus d equals 0. So make the d subject. D is going to be a sine alpha minus mu a cos alpha, is it? A sine alpha minus mu a cos alpha, take a out, so sine alpha minus mu cos alpha. That's the thing they asked to show. First part, that is a part. This is the second method. First method we used energy equations. Okay, so B part now. B part. They are saying that in the question, given that tan alpha equal 3 by 4. So if tan alpha is given, we can find the sine alpha, cos alpha also. It's not a big issue. Tan alpha means you can imagine a right angle triangle. Right angle triangle, this is alpha. Tan alpha is given as 3 by 4. So opposite to adjacent. So this will be Pythagoras theorem 5. So cos alpha will be 4 over 5, sin alpha will be 3 over 5. So I'll write those things also here, easy to handle. So here the given quantities are tan alpha given, but we don't need tan alpha here. So sin alpha is equal to 3 over 5, cos alpha 4 over 5. We'll use that later. So and the question is, I'm going to read the question now, the B part. Tan alpha given as 3 by 4 and mu is given as half, 1 by 2. The portion of friction is given as half. The question is, find in terms of A and G the maximum speed of T. I already explained why there is maximum speed. Maximum speed occurs when the resultant force along the plane down becomes equal to 0, is it? So we'll find that one first. Then after that, we can use either energy equation or the same approach, Newton's second law. By using that, we can find the maximum speed of the particle. So to find the maximum speed of the particle, we should find out at what distance from it the maximum speed occurs. To find it, we will equate the total downward force equal to total upward force. I already explained it. When it moves down, the downward component of the weight, mg sin alpha, remain constant. Friction remain constant, but the extension increase, so the tension will increase. So it will accelerate down, but when it accelerates down, the tension increases, means the downward resultant force along the plane will decrease, but acceleration will be there. When the resultant force becomes equal to 0, that will have the maximum speed or velocity at that moment along the plane down. Beyond it, the resultant force will become along the plane up, so the particle will decelerate and it will come to rest at B. We already found the distance AB. Okay, so here we are going to find the distance at which from A the maximum speed occurs. For that, we are going to equate all the forces acting on the particle along the plane, that is equal to 0. So first we'll find that distance, then we'll use either energy equation or we can use either energy equation or Newton's second law to find the maximum speed. Okay, so when the speed becomes 0, resultant force should be equal to 0. Sorry, when the speed becomes maximum, speed is maximum along the plane down, the resultant force must be equal to 0. That means mg sin alpha, so sin alpha we can substitute, we'll substitute it, minus Fr, friction means, you know that I already told that, friction Fr equal mu r, but r equal mg cos alpha. So minus mu mg cos alpha minus the tension which is acting along the plane up, tension equal to lambda over L into x. Lambda we know 2 mg over L, that is A. X we are going to find. This is the important point here. We are going to find the x. X is the extension from A. Extension from A means that is the distance it moved when the speed becomes maximum. We are going to find the x here. So minus 2 mg over, that's a tension, A times x equal to 0. Okay, so there we need to find okay, we'll substitute mg into sin alpha equal 3 by 5 minus mu is given half mg cos alpha 4 by 5 equal, we'll take it to the right, so we are going to find x now, so I'll take it to the right, that is 2 mg over A into x. Okay, we'll solve it, so it's become 3 mg over 5 minus, it's going to be 2 mg over 5 equal 2 mg over A into x. So 3 mg minus 2 mg, mg over 5, so all the mg will get cancelled. So when all the mg get cancelled, that's going to be 1 over 5, is it? 1 over 5 equal 2 over Ax. So x is going to be A over 10. Okay. So when the distance moved by the particle along the plane down, which is equal to A over 10, not 9, looks like 9, is it? A over 10, the speed will become maximum. Okay, so we had to do this first. So when the particle moves along the plane down from A, the distance becomes along the plane down, the distance or the extension of the string becomes A over 10, the resultant force will become 0. Until that, the particle will accelerate. So when the extension becomes A over 10, at that moment the particle will have the maximum speed. Okay, so after doing it, now we need to find the maximum speed. That could be found in two different methods, by using energy equation or by using Newton's second law. The same idea, exactly the same idea as I did in the previous part, A part. Same thing I am going to do, but the only difference is for x I am going to substitute. That's all, nothing else. So I'll do it now. Okay, so beyond it, I can choose one of the methods, energy equation or Newton's second law. First, I'll do it by using energy equation. So that is the method 1 for the part B. So there I can say loss in gravitational potential energy equal to, now the speed is increasing because speed earlier we found B where the speed becomes 0. So we never talked about, we never consider the kinetic energy. But here the point at which the maximum speed occurs is this one, x equal A over 10. So there is speed. So gain in kinetic energy. When it moves from A to that point, there is gain in kinetic energy plus there is gain in elastic potential energy because the elastic string is extended. Gain in elastic potential energy plus work against friction. Friction I shortly write Fr. Okay, loss in GP, mgh. The distance it moved is x, which is A over 10. But the height I need to find. If it moves along the plane down x, the height is x sine alpha, is it? When it moves along the plane down x, when it moves along the plane down x, if this angle is alpha, the height is, in this right angle triangle, x sine alpha, is it? So loss in GP mg x sine alpha, mg x sine alpha, but instead of x I can put A over 10 sine alpha. Sine alpha I will substitute later, is equal to gain in kinetic energy half m v max square. We are finding the speed maximum. We know at this point the speed becomes maximum, v max square minus 0. Initially it was at rest. Gain in elastic potential energy. Initially there is no extension, no elastic potential. You know the elastic potential is given by half lambda over L x squared. So half lambda we know that, half lambda we know that 2 mg. L we know that A. Extension which is A over 10, is it? Extension is A over 10 all in square. Plus work done against friction, the friction force Fr, that is Fr equal mu mg cos alpha into the distance moved along the plane down is the same thing, A over 10. Okay, so it's interesting. Now we will substitute. Here anyway, m will get cancelled. Yes, those m's will get cancelled. We'll continue. They asked to find the final maximum speed in terms of A and G. So A and G will remain in my final expression. M will get cancelled. So I'm cancelling M and substituting the values of sine alpha and cos alpha also, and also the mu value. I'm going to substitute the values what is given, mu, sine alpha, cos alpha also, and also I'm going to cancel M, right? So if I cancel M, so it will become GA over 10, is it GA over 10 sine alpha 3 by 5 equal to half V max squared minus 0 we don't need to put, plus half M got cancelled. Okay, this 2 and this 2 will get cancelled, so the half won't be there. This 2 and this 2 get cancelled. M got cancelled. So G over A times A squared over 100. So A squared, A, it will become GA over 100. Easy. I wanted to reduce the number of lines. So M got cancelled, 2 and half and 2 got cancelled. So G over A squared over 100, A squared A, so it will become GA over 100 plus mu is given half g, m got cancelled, g cos alpha 4 by 5 into a by 9, a by 10. Okay, so we'll continue further. It's going to be 3GA over 50 equal to half V squared plus GA over 100 plus here this is half, this will become 2, so 2GA over 50 is it. So this 2, here 4, so there will be 2GA over 5 into 100. Okay. So I can multiply the whole equation by 2. This 2 I can multiply, so I'll raise the upper part. Okay, so if I multiply the whole equation by 2, because there's a half, it will become 6GA over 50. 6GA over 50 is equal to V max squared. I multiply whole equation by 2. So here 2GA over 100 means GA over 50. So this will become 4GA over 50. So right side 4GA over 50 plus GA 5GA over 50, so 6GA over 50, bring it to the left. It will become 6GA over 50 minus 5GA over 50, GA over 50 equal V max square. So V max is equal to square root of it. Square root of GA over 50. Easy, is it? Nothing. Same thing like earlier. So this is the method 1 for part B. So I use the energy equation. So that you must be able to identify the energy equations, what is happening. You must be able to identify what changes or what transformation of energy happening. Otherwise you can't get the correct answer, you'll go wrong. Okay, so this is the B part, first method, energy equation. Second method, we can use Newton's second law, but anyway, we need to find the distance at which the speed becomes maximum. That you have to do anyway. Whatever the method, first you have to do that. I did it already, that I got x equal a over 10. Now I'm going to do the second method by using that x equal a over 10. I'm going to do the second method by using Newton's second law. Right, I'll continue that. So this is the first method. So second method, I'll get the same answer. Okay, so we know that the maximum speed occurs when x becomes a by 10, a over 10, yeah, is it? X becomes, yeah, a over 10. That we need to get it. Then we can choose one of the method. Now I'm going to use Newton's second law. Okay, the same equation I'm going to use. Along the plane down, I'm going to use F equal mx double dot. So mg sine alpha minus the friction, that is Fr, that is mu mg cos alpha, mg cos alpha minus the tension, that is 2mg over a x equal m x double dot b dv over dx. So m, all the m's will get cancelled, and I'm going to substitute sine alpha, cos alpha and mu values. So all them get cancelled. So g into sine alpha 3 by 5 minus mu is half into m got cancelled, g cos alpha 4 by 5 minus 2g over a x is equal to v dv over dx. Check it, is there any mistake? Okay, so Okay, so that means 3g by 5. This is 2g by 5 minus, this is again 2g of x, we did your here, then we will integrate it. So when we integrate 3g over 5 integral dx, I'll tell you the limits, wait, minus 2g over 5 integral dx minus 2g over a integral x dx equal integral v dv. Okay, we are going to find the maximum speed when the x was 0 initially at point A. When x equals 0, the speed 0. When x equal a by 10, x equal a by 10, x equal a by 10, we already found that one. The maximum speed occurs, the v become v max. The limit 0 to v max, this is 0 to a by 10, 0 to a by 10, 0 to a by 10. Okay, now we'll integrate it. We'll end up with the final answer. We'll see. I don't think there is any careless mistakes. Yeah, right, okay. So we'll continue. So that is going to be 3g over 5 x, the limits 0 to a by 10 minus 2g over 5 x 0 to a by 10 2g over a x squared by 2, this 2 and this 2 will get cancelled, 0 to a over 10 equal b squared by 2, 0 to v max. Okay, we'll proceed. That is 3g over 5 into a over 10. 0, 0, when you substitute all these x values will become 0, so I don't need to think about the limit 0. So a over 10, when I substitute, this will become 3ag over 50. So then I put x equal a over 10. 3g a over 10 means 550. So 3ag over 50 minus this also 2ag over 50 minus this 2 and this 2 will get cancelled. Here I'll get a squared over 100. A squared, here a will get cancelled, a squared and a, so it will become a. So it's going to be ag over 100, is it? Is equal to v max squared by 2. Okay, so 3ag over 50, 2ag over 50, ag over 100. We'll multiply by 2 now. So 6ag over 50 minus 4ag over 50 minus 2ag over 100 means ag over 50 equal v max squared. Okay, so that's going to be 6ag minus 4ag over 50, that is 2ag over 50 minus ag over 50, is it? When I continue this side, that will become ag over 50 equal v max square. Same answer we are getting it, is it? So take square root. So if I take square root, I write it here. V max equal square root of ag over 50. Same answer, we'll get it. Okay, so the last part of the last question, part C, the question says, describe the motion of P after it reaches B, justify your answer. Okay, at point B, the particle has come to rest. So the question is, will it remain at rest or will it accelerate upwards? That's the question they are asking. Okay, for that, we should be able to find the tension acting on it, because tension depends on the extension. Extension means AB, the distance AB, we need to find it. Now we know sine alpha, cos alpha. So by using the first expression what we got in the A part, we will find the extension or the distance it moved AB is equal to A sine alpha minus mu cos alpha. We'll substitute A sine alpha, we know that 3 by 5 minus mu is half into cos alpha 4 by 5. Solve it, you will get A by 5. 3 by 5, yeah, you'll get A by 5. So A by 5 is the distance it moved from A until the particle comes to rest. So during that time, what could be the tension? We'll find it. Then we'll think about the other forces, friction or the weight, compound of the weight. Then we'll compare, can it have an upward resultant force? Okay, so we'll find it. So in that point, the tension acting on the particle. So the particle has three, certainly there will be two forces, tension and the compound of the weight, mg sine alpha. And friction could act, if the particle try to move up, the friction will act downwards. Or if the particle try to move down further, friction will act upward direction. Okay, we'll find the tension. Tension is given by lambda L, so that is 2 mg over A, 2 mg over A into x. X we know A by 5, so 2 mg over A into A by 5. So that's going to be 2 mg over 5. That's a tension which is acting upward direction. The mg sine alpha, which is acting downward direction along the plane down. Mg sine alpha, how much is it? Sine alpha we know 3 by 5. So that is 3 mg by 5. Okay, when we consider these two forces, tension and the mg sine alpha, so this mg sine alpha is 3 mg over 5, which is greater than 2 mg over 5. So it looks like it could slip further. But if you try to slip further, there will be friction upward direction. We know the maximum friction, that is Fr maximum, that's the limiting friction. We found the friction maximum, Fr max is mu r. We know the limiting friction, that is mu mg cos alpha, mu mg cos alpha, that is half into mg into cos alpha 4 by 5. So that is going to be 2 mg over 5. That's a maximum friction. But any friction can act lower than 2 mg by 5. So it looks like the downward force is 3 mg over 5, the weight, compound of the weight. The upward tension is 2 mg over 5. So if the friction upward direction is smaller than this, 1 mg or mg over 5, mg over 5, what will happen? The resultant force along the plane downwards will be 0, so it will remain at rest. Understand? So the friction acting on the particle maximum is 2 mg over 5, that is the limiting friction. But when it comes to rest at that moment, the downward force, the compound of the weight is 3 mg over 5. The tension is 2 mg over 5. So it looks like the downward force is more than upward force. So it could have a resultant force downwards. But if you try to slip further due to the result difference, 3 mg over 5 minus 2 mg over 5, if you try to move down, there will be friction that could be smaller than this mg over 5. So if there is a friction mg over 5, then that friction will balance the downward force. So there won't be any resultant force. The particle will remain at rest. Okay, this is the maximum friction. So that's the answer. You should say the downward resultant force is downward compound of the weight is 3 mg over 5. So if the friction acting upward direction is mg over 5, the total upward force also 2 mg over 5 plus mg over 5 equal to 3 mg over 5. So the resultant force equal to 0. The particle which has come to rest will remain at rest according to Newton's first law. That's the answer you should say. Okay, so that's all. Interesting paper. Anyway, we have finished all the questions. Any comments or any suggestions, you can put it in the group. Yeah, thanks. Bye.